I believe something is wrong here. We rely on scientific innovation and exploration for so many fundamental aspects of everyday life. You wouldn't be able to watch this very video without it. So why does it feel like society is turning its back on science? I'm Maya, and I want to start this video off by explaining that I really love the process of science. I have a science degree myself, but something feels really off in the relationship that the world has with science today. I believe that both society and science itself have a skewed idea of what science is and should be in the world today. In this video, I want to try to break down where I think things have gone wrong and explain why fixing and reframing our relationship to science matters more now than ever. Before we called it science, it didn't exist. Life just happened. The universe was formed somehow, rocks coalesced, hot liquid magma exploded out of the crust of the earth. Humans sought to understand how and why. Out of that curiosity, humans developed religion, which provided some answers to some existential questions at the time. Now, as more knowledge is accrued over time, and some of these religious beliefs prove insufficient, humans invented science, which provided more testable and reproducible explanations. And so as our knowledge expands and our tools become more refined, science evolves too. And we're going to replace old theories with new ones or refine existing ones. Science is an ongoing dialogue rather than a final destination. I like to imagine that society views science as this cosmic rulebook that's floating through the universe. And all the answers are in that book, and we on Earth are just striving to uncover and match all of those secrets. But science isn't some universal truth that's just waiting to be discovered. We literally made it up. It's a human construct, one that's incredibly powerful, but it's not perfect. Science isn't sacred, and it doesn't exist outside of the human experience. Nietzsche once said that science's pursuit for truth is not too dissimilar from the religious pursuit for truth. To understand this, we need to do a little bit of history. Plato once said, there's the world we live in, and then there's the world of forms. And this world of forms is like this ideal, abstracted representation of reality, one that we can never get to because we are limited by our human senses. But then Christianity comes along. More specifically, St. Augustine appropriated Plato by adapting his philosophy to align with Christian doctrine, asserting that true reality is found in God rather than in the material world. And he's like, this world of forms that Plato spoke of is actually heaven, and God is there, and his word is true. So Plato's original meaning has been shifted. Suddenly this concept of a world of forms has become something that's actually kind of real and something that humans can aspire to reach, even though Plato was like, humans can't do that. Then at the time, most early European scientists are actually Christian, and they are working within a Christian context. They apply their religious framework for truth to the pursuit of science. So now they're saying, there is the world we live in, and then there is the world that is true, the world of science. So Nietzsche's observation is that this emphasis to aspire toward truth, or getting to God, ends up being the very value that undermines the whole religion, because the Old Testament can't survive the scrutiny of science. Okay, so all of this is to say that, like Christianity, science proposes that the universe is structured in a rational, ordered way, and that there is an objective truth which is knowable and worth pursuing. Think of our little book of science floating through the universe. So Nietzsche is provocatively suggesting that this commitment to truth in science is in itself a kind of faith, one that science doesn't critically examine. So he's suggesting that if we abandon religious faith, then we might have to question whether truth really is the most important thing. This then leads to Nietzsche's idea of perspectivism, which holds that truth is not absolute, but is instead shaped by different perspectives and interpretations of the world. To put it simply, truth to one person, influenced by their experiences and interpretations of the world, may not be truth to somebody else who has different experiences and different interpretations of the world. So in this same way, science is just our attempt at interpreting experience. It's just way more robust because it can be replicated by other people who can reach a similar conclusion. Science isn't the final word on truth, but I have this fear that the world is replacing religion with science. And this is a really big problem because science isn't about what's right or wrong or what's true or false. It's a process of inquiry, of asking questions and developing new hypotheses to reach new conclusions, conclusions that can evolve and change. Science is a process. Okay, now I can finally get to the whole point of this video. I think society is deeply confused about what science actually is. So let's ask the question. When we say science, what do we really mean? And more importantly, what should we mean? I'm going to use the COVID-19 pandemic as an example here, so bear with me. During the COVID crisis, we saw science unfold in real time. Normally, it's quite a slow and drawn out process. We develop a hypothesis, we have testing, we make errors, we fix those errors with corrections, then we reach a consensus. And this process is usually spread out over years. But during the pandemic, this was playing out over minutes. That meant that the public was watching the true nature of the scientific process, which is quite messy and involves a lot of trial and error, play out live as it happened. In the heat of the moment, the public was told to trust the science. Governments were issuing urgent recommendations like stay indoors, wear a mask, get vaccinated, and many people followed these orders, which usually meant making personal and social sacrifices. Now, like I mentioned before, scientific errors and revisions were being made in real time. So when the scientific consensus evolved and new data emerged, the same authorities that were declaring that the science must be trusted were actively changing their messaging. Actually, that guidance was not the most effective, but we need you to do this other thing instead now. I think for a lot of people, this kind of felt like betrayal because the stakes were so high. I think for some others, in more extreme cases, this was proof that science itself was untrustworthy. So what was going on here? Well, I think that the natural messiness of the scientific process was being exposed under a harsh and impatient spotlight. This is a process that's usually hidden from the public. So suddenly, when the scientific process is now stripped bare and is being conducted in a big public amphitheatre, those that aren't used to seeing the scientific process are kind of shocked. I think that the big disconnect here was that the science was still being communicated as definitive truth, rather than as a provisional best understanding. This means that each correction kind of looks like a contradiction, and that each mistake feels a bit like a lie. Science was used to being perceived in quite a curated way, so when I had to publicly backtrack, it looked like failure rather than what it really was, which was just course correction. I believe that this misunderstanding led to a big split. On one side, people insisted that the science should never be questioned, and that disagreement was ignorance or malicious. On the other side, skepticism hardened into cynicism, and people concluded that science itself was a scam. But both sides are wrong. For the record, there was nothing inherently wrong with the scientific process during COVID. It was functioning as we would expect it to, especially considering the urgency and the uncertainty of the situation. I believe that the real problem here was in how the public, and to an extent, the institution of science, misunderstood the true nature of the scientific process. Okay, just for fun, let's Google the definition of science. And yes, I'm sitting on the floor when I have a perfectly fine desk behind me, but I didn't want to move all the lights. So let's have a look. Okay, straight off the bat, the Oxford Languages Dictionary says that science is a noun. Then it says it's the systematic study of the structure and behavior of the physical and natural world through observation, experimentation, and the testing of theories against the evidence obtained. That's a very verby definition, despite the fact that it's considered science a noun first and foremost. Okay, so the Cambridge Dictionary considers it a noun as well. Knowledge from the careful study of the structure and behavior of the physical world, especially by watching, measuring, and doing experiments, and the development of these theories to describe the results of these activities. Despite calling it a noun, the definition has a lot of actions and a lot of doing things. Merriam-Webster, let's have a look, thinks it's a noun, a knowledge or a system of knowledge covering general truths or the operation of general laws, especially as obtained and tested through scientific method. Okay, it's prioritizing like its established knowledge. It's a system of knowledge. Let's look at the Britannica. Guys, I'm really dyslexic. Science is a huge field of study. It deals with the search for knowledge about the universe and all that is in it. The search for knowledge. That's really nice. The Royal Societies of Australia. Science is the pursuit of knowledge and the understanding of our environment following a systematic methodology based on evidence. I love that one. It's not saying that science is knowledge, it's saying that it's a process of building knowledge. Let's do one more. The National Institute of Health, however, says that science can be described as a complex, self-organizing and evolving network of scholars, projects, papers and ideas, which is quite nouny. Basically, the whole point of this is to show that it's quite often considered a noun or like a thing, but what I'm seeing in the definition is the description of a verb, of a doing thing or of an action or of a process. And I'm going to show you why I think this matters. Whoa, stop right there. If you're still watching this and you're enjoying it, please consider subscribing. This is my first ever video and it's taken me a lot to make and release this thing. So if you're enjoying it, let me know by subscribing or commenting or whatever. Would really mean a lot. Continue. So is science a verb or a noun? Well, it's both. But my problem here is that I think society focuses too much on science as a noun or as an institution rather than as a verb or an active process. The verb represents the process, fluid, imperfect, and constantly moving. Mistakes, failed experiments, or revisions are not flaws, but are instead essential parts of how science progresses. Science is not the truth, it's just a method for getting closer to it. It's a human creation, and just like humans, it's inherently flawed. But over time, science has become more predominantly recognized as a noun, as an institution or a system of authority. And once we start seeing science as a fixed thing or as a noun, we thingify it. So we give it an identity, we give it a voice, and even an ego. It becomes something to believe in rather than to question. Philosopher Karl Popper tried to challenge this rigid view. He emphasized that science isn't about proving things as absolute truth, but instead it's about falsifiability. This idea that scientific theories are only valid until they are proven otherwise. We should be approaching them with curiosity and skepticism, rather than a blind acceptance. Today, science is often institutionalized and viewed as a final word on truth, separate from society and immune to social influence. But that is dangerous. When we stop questioning it, we lose the essence of science as inquiry. So in short, science the institution, or the noun, says what is right or wrong. But science the verb asks why something is right or wrong, and stays open to changing the answer. My biggest issue here is that I think that science as an institution has a bit of an ego problem. And in the next section, I'm going to unpack the consequences of that, as well as 3 other problems that I see. Okay, so I see 4 major problems that are causing issues and distrust in science today. And the first one, I'm kind of calling science out. Science, the institution, has an ego problem. For a large part of history, people believed that the universe was revolving around the Earth. That changed in 1543 when Nicholas Copernicus proposed the heliocentric model, or that the Earth was revolving around the sun. Despite the elegance of the proposal, his idea was largely rejected by the scientific establishment and by the Catholic Church, which placed his book on the index of forbidden books. Decades later, Galileo comes along and his observations through a telescope provide really sound evidence for the heliocentric model. However, his outspoken views lead to a trial for heresy in 1633, and he's forced to recant and lived under house arrest. Today we accept that the Earth revolves around the sun, but this story highlights a deeper issue. Science as an institution can resist new ideas that challenge the status quo. The institution can gatekeep what it considers truth and dismiss evidence that challenges its authority. This, I will argue, is science the noun, not science the verb. And stories like this aren't just relics of the past. In the early 1900s, many believed that the field of physics was essentially complete. Max Planck, the father of quantum mechanics, was actually advised against entering the field for this very reason. However, shortly after, quantum mechanics and relativity were discovered, revolutionizing science all over again. We still see echoes of this attitude today. People are being advised against studying things like AI or astrophysics, being told that the fields are too saturated. There's a perception that all the big discoveries discoveries have already been made, which just isn't the reality because knowledge is evolving all the time. Nobel Prize winning physicist Steven Weinberg once said that scientific consensus is culture-free and permanent. Now this, I feel, is a slightly dangerous generalization, and I feel like a claim like this is where some of the issues that I have with science are born. So I'm going to break it down. My first gripe is that Weinberg's claim assumes that all science is equal, but this just isn't the case. Like any institution, science can be protective of its paradigms, and rightly so. Some science is so robust, like the need for oxygen for humans to breathe, that we can trust the science without having to reevaluate it every time. But in other areas like quantum mechanics or psychology or cosmology, the data is complex. Oftentimes it's incomplete and it's really difficult to interpret. In these cases, we must be able to recognize why this is different from science that tells us that we need oxygen to breathe, and not treat all scientific claims as equally settled. And even then, well-established scientific knowledge isn't necessarily permanent either. In regards to culture-free, Weinberg's point is that a stone will sink when it's thrown into water in North America or in India, regardless of the culture that it occurred within. In this way, science, the act of making probabilistic predictions based on previous experience, is different from other forms of social consensus in that it transcends social and cultural biases. But science is not above scrutiny. We actually don't know with absolute certainty that the stone will always sink. We simply predict it based on the trillions of times that it's happened in the past. And we can explain when anomalies arise, whether due to the rock's density or the water composition or other factors. All we're ever trying to do is get a clearer understanding of why trends emerge, so that we can make better predictions in the future. The biggest issue that I have with science, the institution, is when it acts as a final authority on truth. If science is like, this is the truth, believe it, and do not question it, then when that truth inevitably changes, people lose trust. They think, you told me this was settled, now it's not. Why should I believe you this time? When science portrays itself as faultless, it starts playing God, and it can act like this exclusive club that alienates others. The solution, again, is that we need to remind people that science is a process, not some finalized vault of knowledge. Its credibility comes from its methods, not its status, and it works best when it's open and transparent, and humble enough to admit when it's wrong. Science is hard, and therefore it's really hard to explain. It naturally alienates the layperson. And this is because it's highly specialized research communicated by experts. So in the world, you might see that to make it more accessible, science communication tends to simplify its findings and tries to make more definitive claims. For instance, let's take climate change. We often use the term global warming to simplify the message, but that oversimplification can be misleading. When people hear that the globe is warming, but then they see something like Antarctica just recorded its coldest winter in 2023, they start to question the science. In reality, climate change is more than just warming. It's increased weather variability, ocean current shifts, disruption of ecosystems, more intense storms, droughts, floods, and even cold snaps in some regions. The problem here is that oversimplified claims that leave out a lot of the nuance can breed skepticism, or can invite conspiracy theories when realities don't neatly align. This is a really difficult one though, because people really like definitive claims. Like, is this healthy or not? Or should I be drinking 1 glass of wine or 2 glasses of wine? Science can rarely provide a yes or no answer without a million asterisks. Or asteri. Or asterixes? So how do we do this? We make uncertainty a feature of science, not a bug. It's like hiking with a flashlight. We can only see so far ahead, and we adjust our path accordingly. And sometimes we hit dead ends, but that's the process. Science should feel comfortable in being able to tell stories of false starts or poor data or revisions that it's had to make along the way. The stuff that the public doesn't see, but literally is science. And this is on society. We should stop expecting science to give us definitive claims and instead understand that it's really hard to communicate. So the publication process is great, but I think it's far from perfect. I think it plays a major problem in the rise of distrust in science. Here are a few concepts that outline the major problems with the publication process. Publish or perish. In academia, if you're not constantly publishing papers, you risk becoming irrelevant. This pressure can force researchers to rush results or cut corners or aim for quantity over quality. Number 2 is publication bias. Journals want flashy, surprising results because they get more attention. This can sometimes push scientists to exaggerate findings or even manipulate data to get into high-impact research journals. Number 3, the replication crisis. Science is all about testing ideas, but replication studies, where one team tries to replicate the findings of another team's results, rarely get published. Journals don't want to publish replicative studies because they're just not as interesting. But without replication, we can't really test the validity of a claim and make theories more robust. We don't actually know which findings even hold up. 4. The peer review process. Reviewers are usually other scientists in the same field, which sounds like a good thing, but what if the paper you're reviewing challenges your own work or threatens your funding? Bias can sneak in, sometimes subtly, sometimes not. Also, reviewers aren't paid. They're busy, and they're probably not always going to be motivated to be thorough. This isn't just inefficient, it can lead to mistakes getting through. There are a lot of different problems with the publication process, too many to cover in this video. But the main point is that science deserves a better system than one that punishes caution and rewards hype. My final point is that science is biased. It's influenced by society, not separate from it. I think we like to think of science as pure and objective, but as I've explained, science is a human endeavor. It's shaped by culture and power and the values of its time. Research isn't happening in a vacuum, unless that's literally the experiment. It needs funding, often from governments or corporations or private foundations that usually have their own agenda. And these funders aren't just investing blindly, they prioritize research that aligns with their own goals, whether that be advancing technology, improving economic outcomes, or maintaining geopolitical power. As a result, certain areas like rare diseases that affect small proportions of the population go underfunded. And this isn't because they lack merit, it's because they lack profit. So bias can creep in at every stage. Studies funded by industry often tilt subtly in favor of their sponsors. Philosopher Brian Latour argued that scientific facts aren't just discovered, they're made. They're built and negotiated and interpreted. Thomas Kuhn showed that science often operates within paradigms. These are dominant ways of thinking that shape what questions are even asked and what answers are seen. And none of this means that science is broken. It just means that we need to stay aware of it. To make science better, we need more transparency, more diverse voices, and more systems that serve the public good. Because science isn't separate from society, it's deeply embedded in it. To serve society well, science must balance rigor with humility. It should invite curiosity rather than demand obedience. Science's greatest strength isn't in claiming to always be right, but in its ability and willingness to question itself. So, where does all of this leave us? Well, we need to evolve the way that we think about science, not just as a collection of facts or as an all-knowing institution, but instead recognize it is a process, which I've said over and over in this video, so I'm sure everyone's sick of hearing me say that. But beyond that, I actually think this video is about more than just science. At its heart, it's a call to embrace critical thinking. I want us as a society to stay open and curious and to ask better questions. In a world full of noise and uncertainty and quick takes, the ability to pause and reflect and reevaluate a situation is one of the most valuable skills that we have right now. And with the rise of AI, it's only going to get harder and harder to discern the truth of something. Our critical thinking skills are what set us apart. And I really believe that it's crucial to the evolution of intelligence. Science doesn't have all of the answers, but it gives us a way to keep looking. And that, to me, is one of the most hopeful things that we've got. if you enjoyed this video, maybe you'll consider subscribing. That would mean a lot to me. As I mentioned earlier, this is my first ever video, so it took me a lot to make this thing. So if you enjoyed it, you can let me know by subscribing. Also, I want to know if you agree or disagree with anything that I've said. This is a safe space for open conversations and respectful disagreement. So if you disagree with anything I said, then I want to know. Thanks so much for watching. Please subscribe because I will be posting more videos. So thanks, guys.